Hi, welcome to complex analysis. This is second session on path integral. In the last session, we talked about what is meant by a path. For us, a path in complex analysis is piecewise smooth. Okay, so we want to talk about integrating a function along the path. What is the meaning? Okay, as I said in the first session itself, do not try to get any kind of geometric idea here. Take the analytical definitions, learn to work with it. Okay, I will try to give some analytical intuition why it was defined like that. Later, when we do the relation between Cauchy's theorem and Green's theorem, you will also see there is a physical interpretation also. Okay, but at present, this is essentially based on analogy. People define that. That's it. Okay, there is nothing like geometric interpretation. Whereas in Riemann integral of a real valued function, non-negative, you have the area as a motivating concept. But we have a definition. Then we what to do is when you want to generalize. Say for example, what you did with integers, you generalize to groups or commutative groups if you want. And if the multiplication is there, then you try to talk about rings. You see that so when you try to generalize, you your example, you just try to abstract and adapt it in a more general context. So that is the best way. Sorry, that is the best way to deal with path integrals. Okay, do not resist. Try to adapt, understand, because many students are bothered with that. Okay, is there any geometric meaning? It's a no. It's one analytical meaning, and it's purely built on analogy of real analysis. That's it. Keep it that way. Okay. So let us start with the definition. So let us start with U an open set in C. Oh, I have not shared the screen. So, and let gamma be a path from AB to U. Remember, this means at present let us assume it's a C1 path. Okay, that is gamma is continuously differentiable. That is gamma prime T is continuous. Alright, and let F be a continuous function from gamma. Remember, this is a subset of U. Okay, so I want F to be a function defined only on gamma, the not on gamma, sorry, the track of gamma to C. This is continuous. So if this is my open set, this is my path, my F is defined only on this track. Okay, this may be like this. This may be gamma. My F is defined only at each gamma t to C. Right? Then I want to define, this is the notation. Earlier notation they used to write like this, but nowadays nobody writes it. This is F is, this is one calls it integral of F along the path gamma. Okay, so what is the definition? Sometimes one also writes like this. This is by definition. This is the definition. This is here to be f of gamma t and gamma prime t dt. That's it. This is the definition. Simple. Okay, right? Don't try to understand any meaning. This is the way you would have defined. Okay, right? How this is something like intuitively work done by the force. Yeah, when moving a particle along gamma. This is just intuition. The way you define line integral in vector analysis with the physical interpretation, you can have that. The analytical interpretation will be, see, I can form a Riemann sum. So I hope all of you have gone through Riemann. Many of you might have gone through Riemann steel just. Then that gives the motivation. So if I have a partition here of AB, okay, this is T naught and this Tn, right? Then I can do various things. Okay, something like f of gamma of Si into gamma of Ti minus gamma of, maybe I can even write it as gamma of T Ti itself. Okay, that's my node. This is a Riemann sum. What is the meaning of this? See, suppose this is gamma of Ti minus 1, this is gamma of Ti, then what you are looking at is this is the line. So you are looking at the line, and on this you are defining f of gamma Ti, the constant function f of gamma Ti, right? Therefore, this is the product. This is I equal to whatever it is, I think 1 to n. Yeah, but then this is approximately equal to f of gamma of Ti and gamma, not approximately, gamma Ti minus 1 by Ti minus 1 into delta of Ti, where delta of Ti is Ti minus 1, right? Right. Therefore, so if you take finer partitions, as I said, remember these are not rigorous, just to give some kind of analytical intuition. Okay, this is not precise analysis, this is not even a very proper way of doing things. I'm just trying to motivate something. Okay, we think that it goes to f of gamma t, and this will go to gamma prime t dt here to be. Okay, taking finer partitions, we turn to this. This is the motivation. Okay, as I said, just assume this is the definition. Okay, now the next thing, suppose gamma is a path in the standard sum, that's why it's piecewise smooth or smooth. Okay, then we have the partitioning interval, right? I will assume the yesterday's notation. Then and again f is supposed to be a continuous function from this to C. Then integral f over gamma is defined to be, I am using yesterday's notation, f of gamma of t, okay, gamma prime of t and dt, where this runs from Ti minus 1 to Ti, I running from 0 1 to n. Remember, on each of the portion Ti minus 1 to Ti, my function gamma is smooth, therefore this integral makes sense. Okay, why the integral makes sense? Again go back, f is continuous and I assume gamma prime is continuous, therefore the product is continuous. And we had already defined integral of any function which is from a b to c which is continuous. We have defined complex integral a to f of t dt. So this integral makes sense, right? So are you following? So note that integral f over gamma makes sense. So in each of the subintervals Ti minus 1 to Ti, this integral makes sense. This is a finite sum, therefore the sum also makes sense. So this is how you define path integral, right? So the best way is to look at examples and work out some somewhat computationally involved examples so that you become comfortable with the notion. Okay, that is the best way to get the hang of the subject. For example, when you learn an algebra, okay, at the 7th or whatever, whichever grade, you would have the difficulty. The only way is you keep working with that, then you become familiar. And again, when you are in, I don't know when it's introduced, third or fourth standard, negative integers, I'm sure you had a difficulty in understanding, because 1 2 3 I think I can count, but what do I mean by counting? Because you understand the numbers is for counting, therefore when I say minus 2 minus 3, what am I counting? So that gives you a mental block. Are you following? So the best way is do not learn how to work with it. Okay, right? So let us work. First example is the same. Suppose I take the interval AB, right? And okay, and this I can think of this in the complex plane. AB real numbers, right? Okay. Then suppose my function f is from AB. So this is contained in C. Now my U is C. To C is continuous. Then I also have a path gamma t equal to T for T in AB. Right? Therefore, gamma is a path in C, and the track of gamma is nothing other than the interval AB. Right? Now I have two notions. I have the notion of A to be f of t dt. This we already defined, because if f is continuous function on interval to C, I have defined what is meant by integral of f on the interval AB. Now I can also define integral of f over gamma as I have done. What is the relation between them? Relation. Okay. So let us go back. So integral of f over gamma, or integral of f z dz over gamma if you want. Okay. Most often I will be economical. I will simply write this. This by definition is integral. You see that I keep writing f of gamma t, gamma prime t dt. Right. So what is f of gamma t? Gamma t is t. Therefore f of gamma t is f of t. And gamma t is t. Therefore gamma prime t is 1. Therefore it's 1 dt. Therefore this is nothing other than integral of a to b f of t dt. Yeah. Pause. Review. Proceed. So every time I will be using this definition. This is the only way I can work with path integral. So till I become very confident, I will keep writing this and then writing the expression for f of gamma t and gamma prime t. Do you follow that? You should also do the same thing so that you become very comfortable and the definition gets into your mind. Okay. Now let us do a problem. Okay. Let us start 1 here and I here, and look at this path. Okay. So my function f of z is mod z squared, and my u is all of c. Right. And my path, I have two paths now. Gamma of t is the line segment path from 1 to I. Therefore it starts from 1 and t to I minus 1. So when t equal to 0 it is 1, when t equal to 1 it is I. So this is the path 0 less than or equal to t less than or equal to 1. Right. Now what do I want to do? I want to find out what is integral of f over gamma. Right. So what is gamma t? So I have to look at what is f of gamma t. So this is equal to, by definition, let me write it, f of, this is 0 to 1, f of gamma t, gamma prime t dt. Okay. Now what is f of gamma t? Gamma t is 1 plus t I minus 1. Right. This is equal to 1 minus t plus it. Right. Therefore f of gamma t is modulus of z squared. Therefore it is modulus of this squared, that is 1 minus t whole squared plus it squared, which is minus t squared. I hope I am doing it correctly. If I am doing something wrong, please let me know. Okay. So this is 1 minus t whole squared plus it squared. Sorry, it's t squared. Did I do something wrong? Yeah, gamma t squared, right? Therefore this is 1 minus 2t plus t squared plus t squared. This is 1 minus 2t plus 2t squared. And what is gamma prime t? See, gamma t is this, gamma prime t is I minus 1. You see that? Gamma prime t, see, let us see, gamma t is 1 minus t plus I times t. Therefore gamma prime t is minus 1 plus I. Right. Now are we ready? Yes. So what is the definition? This is going to be 0 to 1. F of gamma t is 2 minus 2t, oh sorry, this 1, I don't know why I wrote 2 somewhere, this 1 minus 2t plus 2t squared, I hope I wrote everything correctly, times gamma prime t. Luckily gamma prime t, you can see, is a constant, right? That is I minus 1, so I can take it out. Do you remember? This is, if you want, this is into I minus 1 dt, right? And this is a real times this. And what do we know? We know integral of f going to integral of f from a to b is complex linear. Therefore, if I multiply a lambda, lambda comes out. Therefore, this I can take out. Therefore, it's I minus 1, 0 to 1, 1 minus 2t plus 2t squared dt. This is a child's play for us. This is I minus 1 and 1 dt is 1 times 1 minus 2 dt, that is, now I can use usual fundamental theorem of calculus, 12th standard calculus. There are 2 t's, differential of t squared, therefore it's minus t squared between 1 and 2, 0 and 1, right? Yeah. And 2t squared, that is 2, okay, t cubed, the primitive 0 to 1. Okay, this is going to be I minus 1, 1, this is minus t squared, t equal to 1, this is 0, 0, 0 minus 1 plus 2 by 3. So it is going to be 2 by 3 into I minus 1. That is the answer. Okay. Please pause the video. Okay. And if necessary, go through this once more and try to do on your own. Okay. I am going to do 3 more such things involving with mod z squared and mod z squared and two different paths. Okay, so that I want you to become comfortable with path integral. As I said, the only way to become comfortable is don't look for geometric meaning or anything, learn how to work with it. Very simple minded thing. In my book I had given about a lot of small simple examples. Please go through them. That's the way you can master. Right, now the same thing I will do. Okay, f as earlier. Now my path is different and the points are also same. One I, but then take the quarter of the circle. That is, my gamma t is going to be e power I t, and t is from 0 to pi by 2. Notice that the endpoints for path gamma in 1 and path gamma in 2 are the same. Namely, initial point is 1, end point is I, but I want to integrate, right? Okay. So I want, maybe I'll call it sigma, integral of f over sigma. Okay, this by definition is 0 to pi by 2 integral of f of gamma t into gamma prime t dt. Okay, what is f of gamma t? Gamma t is e power I t and its modulo squared is 1. And what is gamma prime t? F of gamma t is modulus of gamma t whole squared, that is e power 2 it, which is 1. And what is gamma prime t? That is I. Right? Therefore, what I am integrating? I am integrating 0 to pi by 2 I dt. That is pi by 2 times I. That's the answer. Right? Now, notice that there are 2 paths in the complex plane. I mean, 2 points in the complex plane 1 and I. There are many ways of joining them by paths. Okay, the first path was line segment, the second path was semicircle. There are a lot more, right? So what I found is when I integrate along the straight line path, the answer is 2 by 3 times I minus 1. And when integrated along the circle, this quarter circle path, it turns out to be pi by 2 I. They are distinct. Okay, that's number 1. Okay, there is this also gives an important observation I can make from this. Remember, when f is from A to B, please pause, review, proceed. So when I think I need to go to the next page. So one important observation. When f was a function from A, B to C, when we define integral of A to B of integral of f of t dt, right? Notice that by our definition, by very definition, real part of this equal to A to B, a real part of f of t dt. Because that's the way I define. If f is u plus iv, then we define integral of A to B of equal to integral of A to B u plus I times integral of A to B v. Therefore, what is the real part of f? Integral f? This is the real part. This is nothing other than A to B u, but this is nothing other than A to B real part of f. Do you understand this? Yeah, this is by very definition. But this is very important. Look at the last example. My function f of z is mod z squared. Therefore, real part of f is f itself, right? Therefore, integral of real part of f over gamma or over sigma is, this is integral of f over gamma. Similarly, integral of real part of f over sigma is integral of f over sigma, because real mod z squared is real, right? But what is integral of integral of f over gamma? That was 2 by 3. I don't remember the answer. 2 by 3 I minus 1. Therefore, if I take real part of this, okay, that is going to be minus 2 by 3. Yeah. So do you see the problem? And similarly, real part of f over sigma, okay, this is the same as real part of f over sigma, okay, that is equal to f of sigma. This was actually complex number, which was pi by 2i. But real part of integral f over sigma is 0. Okay, so understand this, pause, review, proceed. So what you should remember, if I define A to be f of t dt, okay, real part of this is same as real part of f A to b, but integral of f over gamma real part is not necessarily real part of f over gamma. Okay, keep this in mind. Yeah. Okay, now let's look at the third example. Now f of z is now z squared and gamma is as in 1. That is, it's a line segment joining from there to here, right? So there is every possibility I will make some stupid mistakes, okay, because I am more interested in explaining the ideas. So please bear with me, go through it. If there is any problem, you sit down and work out, okay. So what is this? So integral of f over gamma is integral of 0 to 1 f of gamma t, gamma prime t dt. And what was gamma t? That was 1 plus t into I minus 1, which is 1 minus t plus it. Yeah. And what was gamma prime t? gamma prime t was minus 1 plus I, right? That is I minus 1. That's clear because whenever linear thing is there, we know how to compute I minus 1. Okay, right. Now what is f of gamma t? Sorry, f of gamma t is, gamma t is 1 minus t, yeah, plus it whole squared, or since I minus 1 comes common, therefore it may be wiser for me to take this. I do not know. Let me just assume this is same as I minus 1 whole squared. Yeah. Therefore I can expand this. This is 1 plus t squared into I minus 1 whole squared plus 2t into I minus 1. I hope I did everything correctly. Yeah. Do you see why I want I minus 1? Because f of gamma t into gamma prime t, then I minus 1 is common. You see that? If I had done with this, it may be little more cumbersome for me. You see that this is what uh, getting a, instead of simply computing without mindless, kind of without checking things, you will end up with more complicated thing. I do not know. I think this is going to be make my life easy. It's all okay. Therefore, it is 1 plus t squared into I minus 1 whole squared plus 2t into I minus 1, the whole thing into I minus 1. Right? So this is what I want to integrate. So therefore, I have to integrate this between 0 and 1 f of gamma t gamma prime t dt. Now as I said earlier, I minus 1 is a constant, therefore I minus 1 comes out, and integral is a linear thing, therefore integral of 0 to 1, that will be 1, and this I minus 1 whole squared is again comes out, and integral of 0 to 1 t squared plus I minus 1 is common, integral of 2t. Okay, I hope everything is okay. Yeah. If I make some simple mistake, okay, you are much better in computation, you should be able to do it. This is I minus 1, this is going to be 1, the whole thing 1, plus this is I minus 1 whole squared, but then remember this t squared, therefore t squared is going to be t cubed by 3 between 0 and 1, therefore it's 1 by 3. I am just integrating, plus I minus 1 into 2t, 2t is t squared, therefore t squared is 1 between 1, right? This is I minus 1. Yeah. So I hope we have everything. And what is I minus 1 whole squared? That is I squared plus 1 minus 2i. This goes, therefore 2i. Therefore it's going to be I minus 1, 1 minus 2 by 3i plus I minus 1. So this is going to be I minus 1. This 1 and 1 cancel. This is a minus 2 by 3. This is plus 1 by 3. Therefore 1 by 3i. Therefore I by 3. So this is going to be 1 by 3 into I squared. This is minus I. Therefore minus of 1 plus I. Right? I squared is minus 1 and this is minus I. So take minus I. This is the answer. Okay. Please, I hope I did it correctly. Okay, okay, I might have goofed somewhere, but you know the answer. I mean, not you know the answer, you know how to compute. Go slowly because I want to finish the lecture, so I do that. Okay. So this is minus 1 by 3. Now let us compute the same thing with respect to circle. Now let us look at sigma t e power I t 0 less than equal to t less than equal to pi. Therefore, what is f of gamma t? F of gamma t is e power I t whole squared, which is e power 2 it. Is that okay? Yeah. And what is gamma? Sorry, sigma. And what is sigma prime t? It is I e power I t. Yeah, therefore integral of f over sigma equal to integral of f of sigma t into sigma prime t dt 0 to pi by 2. I hope everything is correct. Okay, yeah, and that is this e power I t, there is an I, therefore it's going to be I is coming out 0 to pi by 2 and e power 3 it dt, right? This is e power 2 it and there is an I here, that I came out on e power it, e power 3 it, but this is I into e power 3 it by 3I, and this should be evaluated between 0 and pi by 2. Where is my cursor? Oh, it is here. Okay, let us do that. So this is going to be I, and 3 power I 3I times t, 3 is t equal to pi by 2, that is 3 pi by 2, that is e power I 3 pi by 2 is e power I pi into e power I pi by 2, therefore it's minus 1 into I, therefore it's I. There is an I and there is also a 3I common, so let us take it out. I, and that 0, it is 1, so it is going to be, so take the this is a minus I, right? Yeah, I forgot, I said minus I wrote it wrongly there, right? This I cancel, therefore minus 1 by 3 into 1 plus I. What are the answer last time? Minus 1 by 3 and 1 plus I, it's the same. Yeah, right. So find something very interesting. When I integrated f of z equal to mod z squared with along two paths with the same endpoints, initial and terminal points are the same, I got two different answers. The answers are different. But when I took z squared, when I tried to integrate along to the same kind of paths, the answer seemed to be the same. Okay, and those of you had already seen my holomorphic functions, Cauchy-Riemann equation, etc., you will already get some kind of an idea. What is that? Do you remember? A real valued function cannot be holomorphic unless it's a constant. Therefore, mod z square is not holomorphic, whereas f of z equal to z square is holomorphic. So when it comes to holomorphic, something happens. Okay, the integral of path equal to something. It's independent of the path except for the endpoints. But then some, this is not exactly correct. Don't believe this. Okay, there is some kind of extra conditions I have to impose at present. Just to mind, there is something interesting happens. Right? Does that remind you of something? If you had done two variable calculus and you would have learned something like line integral of, okay, line integral of a vector field along a path, you would have seen it is independent if the vector field is conservative. That means if capital F is a vector field, f of xy equal to something, okay, u of xy comma v of xy, that's a vector, then if that capital F comes as the gradient of a function, smooth function f, that therefore u of xy equal to del f by del x, v of xy equal to del f by del y. Okay, that means capital F has some kind of primitive. It comes from something differentiable. Again, if I followed my lectures on what is complex analysis about, I already said that any holomorphic function is locally a power series. That's what Cauchy's theorem tries to say. And any power series has a primitive. Right? These are the kind of thing which gives some kind of a vague idea why I expect for holomorphic function, at least in small places. Okay, in open disk you will see, if I take any path, the path integral will depend only on the endpoints, not on the path. Okay, and of course this is correct statement on this. These are the things we are going to do. I'm just trying to build up the tempo. Okay, and some of the things may be slightly over. That's okay, don't bother. I have to keep repeating so that you know what complex analysis is about at the end of the course. Okay, we will meet again. Bye.